Hey guys, Kim here at Papa's Fix-It Shop. And today I'm working on a suppressor for my Blackout 400 Blackout Rifle that I made. And some of you might have seen a clip earlier when I talked about it. Well, this is where we're going to get going. We're going to machine out a bunch of cavities in a piece of aluminum to make spaces, so when the bullet passes through the center of the suppressor, high pressure gases generated go up into the edges, because there's a tiny hole in the middle and it's hollow around it, so it fills all these cavities, and then once the bullet leaves, then it depressurizes out the front. Now, tests have confirmed that it actually gives the bullet a little bit more oomph on the way out, but we're talking like it's, trying to move a feather by blowing at it from a mile away. But yeah, in any event, I have a license, or what you would call a tax stamp, for it, and it's my own design, so I'm the manufacturer, and it's completely legit. So let's get it, or get with it. It's been a long week, guys. Yeah. Okay, so first, a little general information. If someone's trying to do this kind of thing, you have to understand that this mill is a benchtop mill, and it works good. I can make it do stuff, but you don't want to push it too hard because it's tiny. It don't have a lot of weight. I can pick it up. So you have to make sure everything's tight, like your lockdowns where you stop the slides from moving, and then there's a set of locks for the tower when you move it up and down. But more importantly, everything you do with this machine, one of these small machines, you have to start at the shortest possible distance. In other words, you don't want this spindle hanging out very far, because it's all very lightweight. It's great at making, I've made some pretty dang precise stuff with it, but it wants you to be patient. I guess that's the best one. So now I'm going to center this shaft with a wobbler. I'm sure you've seen that before. Where am I at? I'm there. I am not there. Hold it, I gotta do something real quick. So, okay. This handle down on the mill right here, I guess you can't see it. It was getting loose, so I had to stop and tighten it up. So I'm gonna take her back all the way. Where is it? I'm going to clean these ways off right here, because these out in front get a lot of dirt. Just throw a couple squirts of whale oil, and here we go. There it is. Okay, if you saw that, that guy just shifted. And at that exact point, I'm going to move the camera. That's not too good. There we go. All right, so you can see the DRO here. This is the x-axis that's going that way, so that's the one I want. Right now, it's 38.975 millimeters from the end of the travel, not from the end of the pipe. So what I'm going to do is, I'm going to say right here where X, see it goes blank? And then down below you can see a 1/2 sign. Press it. Now, it tells me 19.485. So what I'm going to do is I'm going to bring it up. I'm going to push back under it. Of course, this is in millimeters right now. I prefer millimeters myself, but I've been around metric crap a long time. So now I'm the zero axis, the x-axis is at 0, and the spindle is positioned right center on that bar. Now, for fun's sake, you could now move. Let me move this to tell you. If you really want to be Mr. Uber Precision, you could run the table that way until this guy's over on the other end and do the same measurement again. And see if they both read the same one, you know. And in that one I would measure, I'd go all the way to the end of the travel, set it at 0, then bring the table back in to where I could check it on one side or the other. And if you take it to the end of its travel and 0 it and then go out, you'll get a number of how far you've traveled to get this indicator to contact the piece. And it's kind of a quick way to see if it's parallel. So, and somebody's going to say, well, that can't be parallel. It's too many variables. Yeah, you're right. I'm not looking for 0.0001. I'm looking for, I can't see it with my eye. And that's going to be in the, depending on person, somewhere between 1/1000th and half a thousandth. So for the purposes of this device, it's not uber precision. Otherwise, I wouldn't be doing it by hand. So now we go on to the next step, cutting holes. This is good practice for learning how to make big chips or small chips. I go for like a 1/2 inch. Like a 1/2 inch long tip. It's at about 11 millimeters so far. Got a way to go. Too much lube? Ah, I just hit the center. So okay, now I've gone through the bore that goes through the center, and I'm at about 15.5 millimeters. So it's under 15. Let's see. Alright, I'm talking solid metal now. I'm going to go all the way out the other side. que muy sabroso. Yeah. So anyway, it's first day on this part, and I've managed to drill a hole in a round bar. So that kind of explains how you gotta like make sure that you're doing what you want to do to get the result that you want. And this is the voice of experience talking. I've destroyed more raw materials than I care to remember. So anyway, if anybody doesn't understand that concept, I invite you to think of something you make and don't put anything on paper. Don't think about it. Just say, I want X to do this, and walk out and start trying to build something and see how many times you throw it away. So I'll give you an example. Here I am. So I made this pipe. I like pipes. My dad smoked a pipe. My grandpa smoked a pipe. My grandma smoked cigars. That was weird, and she smoked a pipe. And this is, let me get a closer look. Actually, you know, the bowl comes off, and it's all wood. Well, what you don't know is that there's a piece of copper tubing that goes all the way through here. This is the 7th attempt, and it's a discard, so I kept it. Because I just went at it thinking, I'll just do this and that. It should be easy. How hard can it be, right? And I trashed a bunch of material. So what the hell? See you later. So you can see 2 slots right here. And what I do is I drill a hole and then I go over and take about half of the other hole. It'll enable me to end up with 10 chambers. And then I have the other part, which is an expanded one. So it's going to be in the 11 to 12 chamber range, which works for me. So, I mean, that's the first step. I'm going to go down here and cut all of these slots. And then I'm going to come back and widen them out so that they have more space inside. And that's where the gases expand into those empty cavities as it goes by. And it basically muffles the sound. It's like a baffle. So that's the plan, at least. Let's see. So I'll go over here. I got a tiny little scratch mark that is where I'm trying to reference off of. Right about there. Yeah. I'll lock that. There's the center hole. The WD-40 just keeps the chip from sticking. Aluminum will melt and grab onto the steel. farted around too long and let it get hot. Yeah, you can't be messing around. Hey guys, we're back on this guy, so I'm going to zoom in and look at this, but before I do, I'm going to tell you that what the plan is. I went down the center, made a 1/2 inch hole with this mill, and then made it into a groove, kind of like about 1.5 times the diameter of the mill bit. Anyway, so then what I did is I went 7 millimeters to one side. On this side, I'm going to go to the back. This is where it screws onto the gun right here. This is where the bullet enters. And then on the other end of these little grooves, the opposite end right in here, I'm going to go 7 millimeters across and go down, and then do it all the way down here and then all the way up the other side. So it'll make, for lack of a better word, kind of a T-shaped opening. That's the plan. All right. Okay. All right. So what I'm doing now, might be able to see this. I'm taking the same end mill and drilling a hole all the way through on this end of the little opening I made. Essentially, this is the side that screws onto the gun, and I'm going to end up with making like a T-shaped, roughly T-shaped rounded hole through there. So on this end, when the gases come out as the bullet passes, they'll expand to the front of this guy and ricochet back the other way. So, that's the plan at least. I just have to get all the holes drilled and then deburr them. So watch us drill a hole. So right now, the end of this guy, I'll take it down. Right about there. It's 36 millimeters to the other side. Just for shits and grins, in case you wondered. Sneak into it until I got the full contact. Okay, now I got full contact with that bit. So then I go steady. I got 30 millimeters to go. Down there, I never went far enough down. Yikes! But this is rough. So this is what it looks like after I drill it. You know, three half-inch drills and 1/2 of it. Then I go in and I mill it out again, and this is what they look like when I'm done. See? That one I could have taken. I'm going to have to come back and take more off of that one. All I wanted is to be as smooth as possible. So yeah, and that's all just manual stuff. You know, go this way, go that way, go the other way. Right? Right. Oh, tiny, tiny little blemish right on the edge. We'll go like here. Go right about there, and I'm going to go backwards, forward, back to the middle, back to center, perfect. So that part where I moved it, so basically I went this side back and forth, got that all, this edge right here all cleaned up. And before I went all the way down into this pocket, I stopped part way and went back and forth and knocked these corners off. I'll give you a better look next. The corners. Barking dogs. Let's see if it's getting closer. Too many knobs to tighten. Oh. That's more like it. Oh, you're running too, huh? Let's see. Yeah, there we go. Got out of position because I'm doing it wrong. Got to be at 7 the first pass. I got to go down first. There's a completed piece. It's a Maglite, right? And so you can buy these ends online that are tapped out for a rifle. There's one that fits like a 308, and there's one that fits a 226. You know, like a AR-15. Well, anyway, you know, I messed around and I got busy, and the last bit of the video showed me finishing the holes, but then I had to go in with a die grinder and clean them all up to smooth it out, and then I sandblasted it. So this is what it looks like. See if you can see that. That's the whole thing, right? From the side it looks like this, but like that. So I think I showed this. I don't know if I did or not, but this is, I can't remember where I got this. It's been so long. But this guy fits just like this inside the gun, right? Bullets come from this way. This is the muzzle. This guy's got holes all in it every which way, and this little lip is designed to let those gases that go out in here to go back out. So that's about all it is. And then you take your Maglite flashlight, drop it in, take this guy, drop it in, screw this guy in, and there you have it. Get back here where you can see it, huh? It's a D-cell Maglite. And I don't know if you can see any of this. but probably a bad place. Let's do this. See? Kim Condi, Yuma, Arizona, model KC308. And then there's a serial number. That's all there is to it. So this is the rifle, the 300 Blackout. Let me flip it around. That's pretty crappy. Anyway. Yeah, a little pocket there. Put things in. This is the gun. I built this gun out of parts. And it came from Triton. Triton is a local gun shop that they focus on these kinds of weapons. ARs, 300s, 400 Blackouts, AR-10s. Yeah, if you need something, that's a nice place to go to. So this is, I got to take this little muzzle off and put the suppressor in there so see what it looks like. Stand by. So here's that 300 Blackout with the suppressor on it. It's a long sucker. Now, you might ask why I want a suppressor. Well, it's because I already have serious tinnitus from gunfire and explosions. So I don't need to make it worse. Having a suppressed rifle is a lot better for the public when you're out at a range because you're not making a lot of noise. So that's that. But yeah, I love this rifle. It is so sweet. Actually, I had a few problems when I first built it. It wouldn't cycle properly, and I found out that the gas hole, you know, can't see it from here, but there is a, let's see that little shiny thing in there? That's the gas tube that goes up here and connects to the barrel so that some of the gases come up through that tube and cycle it, you know. It makes the, you know, the bullet goes back, and that gas tube is what helps the receiver cycle back. And I had to go in there and widen that hole a little bit. Problem solved. Yeah. So that's the rifle. That's the whole purpose of this little activity. Now I got to take it to the range and shoot it and see how it sounds. See if I can get a video of that, but it ain't going to be on this video because I need to get this thing done and out. Thanks for watching.